Okay, so today I'm gonna get started with the upcoming storm that is coming into the Los Angeles, the Southern California area. Um, the storm, there's been a bit of a change from the last time I did this video, which was yesterday, which um high resolution models are finally coming into view of Friday's storm, which is not really a storm, it's just but okay, starting off with Los Angeles here, this is gonna be Los Angeles. Now here's a HRRR, and this is for Thursday at midday. Thursday at midday, I could get closer. Thursday at midday, we're seeing it's showing that there could be showers starting tomorrow. In the last video I did yesterday, it was barely showing that that rains were gonna happen. Maybe less than 50% chance. Like it was a 50-50 chance if they were even gonna happen Thursday night. So now HRRR, which is just one model, but I'll explain. I'll go into depth later. That even as soon as at any point during tomorrow, this one has a 9 a.m. Here's a midday. That showers are gonna be starting in Los Angeles as soon as tomorrow, like morning or midday or at any point during tomorrow. Like now, for temperatures, today was a hot day for Los Angeles. I would say most people would say anything over 65 is a hot day, and today it got to like 77. Now, but this is like the last day it's gonna be like that compared to tomorrow, which tomorrow we're probably not even gonna reach up to the 60s. If I go to an ensemble of this tomorrow, we're seeing less than 60s. It's not even reaching 60 degrees tomorrow. If these models are correct, if I go to multiple models, here's an AM for tomorrow. And this is showing, yep, also not going up to 60 tomorrow either. So tomorrow's going to be a really cold day in Los Angeles compared to today. And as I mentioned, that rain, let's see what, here's a high resolution ensembles of the most recent high resolution models and multiple models. Like the one I showed was the HRRR, which is down here. If Los Angeles is basically going to be like this, you could tell where Los Angeles is in California because it has like this peak where the beaches are. There's like, and multiple models. This is for tomorrow at midday, Thursday. Multiple models are showing rain in the area tomorrow in midday. So this is a recent development. I don't think this is something that was. I mean, I didn't see it yesterday and I did it last night. So this is something that just barely came up today. Here's the EPS. This was the most. This one was the. If you remember from yesterday, this was the model that was least showing rain for even Thursday night, and now it's showing Thursday midday 65% chance of rain for midday tomorrow. So there's an even, I would say there's a 60 and above chance of rain for tomorrow at some point in the Los Angeles County area. And it's going to be a cold and possibly rainy day tomorrow, a really cold rainy day tomorrow. Now, if to go farther in advance into the what I thought was gonna be the proper day, if we go into Friday, here's the rain server for Thursday. For Friday, you start getting these shower cells moving into the area, which appear to have strong rain with them. So, at any point during tomorrow or Friday, I mean, we could be having these look like convective showers to me, which this brings a risk of any like rain, heavy rain with maybe some strong winds. Now, if I take a model sounding, these rains at the beginning of the day, like this is a very like strong rain. These are very hard to, convective rain is very hard to predict, like exactly where and when. if this is there is some convection with it, but okay. So these morning showers look like to be like low risk of just rain. But once we go to the rains that start later in the day, let's say the problem with rain that's like this, that's like cellular like this, is that it's hard to like tell at what time it's gonna be happening. And like any of these could be moving, could move in any direction, even though like this one has it up here in the Inland Empire, it could still go down. So let's say there's rain at, let's see if this is a good time. Yeah. Okay. So let's say that there's rain. This is for what time is this? This is for 20 Z. So let's say about um this is like for like 2 p.m. Let's say there's a shower, a storm at that time. If I like I said before, this is a SQT, which basically is the temperature and the moisture in the air going up into the atmosphere, starting at the surface at 0 kilometers all the way up to 15 kilometers in the air. Now, here's the temperature lines. You can see that it's called a skew T because the temperature and dew points are skewed. Like here's the 0 Celsius, for example. The 0 Celsius is this blue line and it's skewed to the right. That's why it's called a skew T. Now, an important factor of thunderstorms is that the top of the clouds, like let's say there's a cloud, for example, a thing that's common in thunderstorms that creates thunderstorms is that you want the top of the clouds, so this area, you want the top of the clouds to be at a -20 Celsius or colder. Now, a skew T gives you the estimated top of the cloud area as this, the EL. The this is if this was a cloud, the LCL is the bottom of the cloud, the EL is the top of the cloud. So a cloud would be approximately in this environment would be this like the whole height of the cloud would be from the LCL at the bottom to the EL at the top. The -20, which I said is the area that if the top of the cloud is colder at a -20 or colder. If I here's the -20 right here. If I trace the skew T up to the red line, which is at the temperature of the atmosphere at that height, you can see that the -20 is here. And if I trace it to where the cloud is, you can see that the top of the cloud is way cold. -20 is here. So the top of the cloud is colder than -20. So that's a sign that these storms in the afternoon can be thunderstorms. Now, another thing that I didn't mention is that, okay, so this dashed white line. Let me make it a different color, like blue maybe. This dashed white line is your partial temperature, which is basically the temperature of the red line is the temperature of the atmosphere, the whole atmosphere in general. But the dashed white line is the temperature of your parcel, which is basically, let's say for simplicity's sake, is basically the temperature of the inside of your cloud. And if the inside of your cloud is warmer, aka if it's to the right side of the atmosphere temperature, which is the red line, if it's to the right side, if the blue line is to the right side of the red line, that means that this area is unstable. This is your instability or your CAPE. Now, anything over 100, when it's near the -10, is instability good for thunderstorms. And since here's your -10, and there is space in between the red and white line, or blue, because I colored it blue, since there is space, and these numbers are saying that here's your CAPE, this is your CAPE category, and you go down, and it's saying that, and most of these are over 100, these are 300, 200. That means that this is a good environment for thunderstorms for tomorrow, for the Friday afternoon in Los Angeles. But there's a low chance because thunderstorms are very hard to predict, in my opinion, in Los Angeles specifically. But it is if they're, because they could be too dry. You only usually want this is your moisture. Usually want this for like 50 or above, and here it's at 40. So I would say that there's a slight chance of thunderstorms um, Friday afternoon in Los Angeles. And here's your day temp. I mean, this is what I said. There's like 1 p.m. uh Friday, and look, it's not even it's at 53 in the day and Friday. So it's gonna be a very, very cold Thursday and Friday in Los Angeles. Now, let me erase all that. So basically, to sum it up, possible rain starting Thursday, and most likely rain starting on Friday, and both Thursday and Friday are going to be cold. Possibility of thunderstorms Friday at midday to afternoon in Los Angeles County. Now, moving on to a different topic, is for the possibility, the small but non-zero chance possibility of tornadoes in the Central Plains on Saturday. Now, this is your Saturday, April 6th, I believe. Saturday, April 6th. Here's the picture of the atmosphere at 5 kilometers in the atmosphere. And here, as I mentioned before, is if you follow the black line. No, I don't follow that one. I'll follow the one under it. If you follow the black line, you see that it has a U shape. So this is your trough. So your trough, and a trough is an important factor in the creation of tornadoes. Um, anything in the green or any other color that's not white, for example, let me just color in anything that's not white, is your 30 knot winds. And this is saying that, oh, this is good for supercells, which is the creation of those are the type of thunderstorm that create tornadoes. So first you need a supercell to create a tornado, but not all supercells create tornadoes. But this is saying that, okay, this environment is good for supercells. Now I'm just gonna go to the surface and look at my dew points. As I mentioned in previous videos, your moisture is you need moisture in the lower levels. You need moisture in the surface for tornadoes. Now, usually you want this over 60, and as you can see, 60 is anything that's blue and above. And you can see your 60s are down in Texas. And there is some cases, and it's just like a case by case basis, but there is some cases where anything, even in the anything 50 and above, is good for tornadoes. Now you see this is specifically for the College of DuPage weather model site, but there's like these red, like here's a red, like a circle, here's your another red circle. Those are your lifted index levels, and basically that's like measuring your instability. And you can see there's a pocket of instability up in Kansas with 55 dew points, 54, 55 dew points in Kansas. Let me zoom into that area. You can just go up here, Central Plains. There's a pocket of instability with 50 dew points, 55 dew points here in Central Kansas. It's over. If I go back to the 500, it's in a area favorable for supercells. And let me just color anything that's over 50, which is basically anything that's in a darker green. These are 50s. And there's a sharp difference between, like, this is Kansas right here, and there's a sharp, here you have 52 dew points, here you have 35 dew points. There's a sharp difference in your dew points. So this is your dry line, which is your area is going to be your area of creating storms. Storms form on boundaries. Basically, you can either have an area that's an area of warm air crashing into cold air. You can have an area of cold air crashing into warm air, or in this case, you have an area of dry air moving into an area of humid air, which is your dry line. Now, I already checked the box that area is good for supercells. Now, to check for if there's low level winds, is your 850 wind speed. Anything that is yellow, here's your legend. Anything that is yellow or a deeper color like red, purple, is an area that has your low level jet, and that's a very, very important factor for tornadoes, is that you're in an area that has a low level jet. And everything, basically the whole area that I colored green, which you can see right here, the whole area that has your 50 plus dew points is in a low level jet of 40 to 50 knot winds at 850 millibars, which is about 1 kilometer above the surface. Now, I'm gonna go down here to your convection, and here's your CAPE values, which is your instability. And like I said, anything over 1,000 is good for tornadoes, but there's, in these cases where there is not high dew points, there's also, you don't need that high of CAPE. So let's see the CAPE here. Here you have CAPEs of 300, which this is not very high CAPE. What's nice, your surface CAPE? Your surface CAPE, that's more like anything that's like in this, like in the 6, 7, 8, 9 CAPEs is good. So let's take a sounding. Remember, when you left click and hold for 1 second and copy the page. If you left click, I'm gonna left click right here where there's a 714 CAPE. Let me hide this. Give it a sec. Okay. Now here is your sounding for that area. And like I said before, here's the things you want to look for tornadoes. You can see here's your temperature across the atmosphere. You want these to be less than 15 or 20. So 54, 64. There's a good thermodynamics for tornadoes. You have a 54 over 70. You have a 930 surface CAPE, but you have 340 mixed layer CAPE. You have no convective inhibition, but anything that's over -30, so -31, -32, that's higher. You have a higher inversion in the atmosphere. Your LCLs and your LFC is a little high, but here it's less than 1,500 and less than 2,000. Your LCL here, LFC here. So this is high, but it could still create storms, or it could be there's a good tornadic environment. Now here's your, like I did in the Los Angeles one, here's your LCL, so your bottom of your cloud, and here's your EL, the top of your cloud. And this is very, you could expect low, because the moisture is so low. Probably this is going to be your low top cells. Usually in tornadic environments that are like above 65 dew points, your storms are like go way high in the atmosphere, but you're going to have low top supercells. Your 3 CAPE, you want this over 50. Here's at 84. Your lapse rates, so the temperature, how cold your per kilometer the temperature is getting. Here it is at 8.9 and 6.3. 8.9 is a really strong lapse rate. That means that for every kilometer you go up into the atmosphere, it's dropping 8.9 centigrade. Now here's your kinematics. That's your thermodynamics, and these are pretty adequate for tornadoes. Here's your kinematics. So here's you want this number above 150. You want over 100, and then you have it at 192. You want this over 200. That's good. Over 100, that's good. Over 30, that's at 70. So this is this is a good favorable for supercells, which is the precursor to tornadoes. Over 15, you have it at 31. You have your winds backed, meaning they're coming from the, if this was a, like, let me draw it right here. This is your coordinates, essentially. Um, usually for your surface, these are your winds, right? These are wind barbs, as I said. And usually the point where the pointy part is the direction the wind's coming from. So if I had a wind barb like this, that means that the wind is coming from the south because it goes like this. The pointy part is where the wind's coming from. So this is at the bottom, it's coming from the south. If I had a wind barb like this, that means the winds are coming from the north. If I have a wind barb like that, that means the winds are coming from the east. Now, for tornadoes, usually you want them to be coming from the southeast. And that's exactly what's happening here. You see it's curved like that. It's not straight, it's curved like this. So, and you want them over 15. So you want them, you want them over 10 or like 5, I mean. So you don't want a short stick, you want a long stick. You either have a long stick or a short stick. And a short stick is a 5, a long is a 10. Is a 5, yeah, it's 5 and 10. So two long sticks is 20. That's I didn't do that right, but long stick 10, short stick 5, and here you have a good winch here. Now here's your 850. Your box is red, that means you have a warm air advection at the bottom. Here's your hodograph. It's curved, especially in the pink one. The pink to red is curved. That means you have strong, you have good hodographs for tornadoes. Here it's at 57. You want this over 45, so 57 is good. And you see the possible hazard type is tornado. Now these storms are going to be moving pretty fast. If they form, they're going to be moving at over 50 knots. This is your direction. This is basically like these, but like here's your north, west, east, and because you follow this blue line to the right mover, and that means your storms are going to be moving to the northeast at 50 knots. And but one thing that I saw earlier that could mess up this storm is or this day, I mean, is that as your shear boundary. Now, like I said, that you need a boundary to create storms, and the boundary that's creating the storm is probably this dry line. No, yeah, let me try a different color. Orange. Storms are probably going to be forming off of this dry line. And if you go to convective and then most unstable cape / shear, your shear vectors is basically your wind barbs. And your wind barbs here, your shear vectors, they're in this like gray zone between if they're gonna be discrete or linear. Basically what that means that if it's a linear storm, that means that it forms like this. Like all the storms form like together, and because tornadoes take up so much energy, these storms come because they're so close together, they compete for the same environment, and so none of them can really form are not really like they're competing for the same environment, so none of them can like become mature by itself. Meanwhile, if you have discrete storms, you have storms that are like this, or like they're all by themselves. Now, when the shear vector is parallel, like this, like if your shear vector is like this, that means that storms are going to be most likely to be favorable for linear. Meanwhile, if you have your boundary and the storms are like this, that means that storms are more favorable to be discrete. And here you can see that they're kind of in between. Like it's not full straight, like it's not full up like this. They're not parallel like this, but they're not perfectly perpendicular. They're kind of like in this gray area. So you might be in an environment that has more favorable for either linear, maybe discrete. It's gonna be like as we get closer to the day, um, it's gonna be more obvious what it's gonna be. Like right now, if I go to simulate reflectivity, you can see that it has a storm that's like The storms that are firing are like more like lined like this instead of being like this by themselves. But you have some storms that could be like that, so it's just gonna be a wait and see for that day. So, and also another issue with this day is that here the GFS is predicting 50s dew points. The European model, here's European model. Let me go into the Central Plains. Now let me do a similar thing that I did with the GFS. Here's your dew points, and it's also predicting 50s dew points in Kansas. This is most likely going to be a Kansas event because that's where your instability is highest. Is your 50s dew points. 500 is for anything over 30. Here's at 55, so 850. Anything over 30, here's at 40. Now your instability. The European has way less stability. If I go to most unstable, there's better numbers here, but they're still not that high. If I take a sounding here, this has no 3 cape, and that's a very important factor for tornadoes. It has 0 3 cape. You want 50 or more, and here it has 0. So there's a lot of 0. So instead of a tornado environment, European is showing more of a hail environment. Because if there's no 3 cape, this hail environment is basically a tornado environment. If it's missing some tornado ingredients. So because there's no 3 cape, which is one of the most important factors for tornadoes, this is instead of a tornado environment, it's turning into a hail environment because I don't see any 3 cape in here over 50, unless it's somewhere else. But there's not that much instability at all in the European model. In the North American model, the other problem with the North American model is that dew points don't even reach 50. Maybe down here. What's the cape here? You have some cape down here. Do you have 850? Yeah, you do. So let me check down here. You have 850s down here. There. Here in this environment, the dew point and temperature is way over the 20 minimum. It's way over the temperature and dew point is way different. So this is favoring more of a hail and wind environment when the bottom of the QT looks like a V shape like this. So this is what I colored in the dew point and the temperature. When the temperature and dew point make a V shape like this favors more of a wind environment. There's not even 3 cape here either. So we're just gonna have to wait like a day or two to get closer to see what the environment is gonna be. So there's probably gonna be another update. But for now, that's all for me for today.